Hiya, it's Mr. Baker here, and today we're going to be looking at Newton's first law. So we're going to be looking at Newton's first law today. Over the next few lessons we're going to be looking at Newton's three laws of motion. This is the first lesson really of the forces of motion topic that we're going to be looking at. Okay, so let's go straight into it then. So if there are no forces acting on an object which is not moving, it will stay at rest. Or if it was already moving at a steady state, at a steady pace, in a straight line, it will continue to move in a straight line as it was before. So to start something moving, or to speed it up, slow it down, or to stop it, or to change its direction, a force must be applied. So, what exactly is Newton's first law then? So, if the resultant force acting on an object is zero, all the forces are said to be balanced. Now, if you can remember, a resultant force is when we add up all the forces on an object and we come up with like all of those, the sum of those forces we sort of say is the resultant force is like one force. If all of the forces, so the resultant force acting on an object is zero, then we would say that the forces are balanced. And this really is the basis of Newton's first law of motion, which says if the force on an object, if the forces on an object are balanced, the object will continue to do whatever it's already doing. And that's basically it. So if it's stationary, it will remain stationary. If it's moving, it will continue to move at the same speed and in the same direction. And that is basically what Newton's first law is. Now, it's very unlikely that you're going to have to write down what Newton's first law is. So what you've got to be able to do is really just to understand what this is. And it's intuitive. We live in this world and every day we use the ideas of Newton's laws every single day. We know them. But to use them every day is slightly different to then actually having to write them down and then eventually to use equations and things to describe them like we would have to do in physics. But if you just think about the real world and what's going on in the real world, then you will be able to understand this. So if the forces on an object are balanced, the object will basically continue to do what it's already doing. If the object is stationary, it will remain stationary. If the object is moving, it will continue to move at the same speed in the same direction. Now I say it's intuitive, but actually our everyday experiences are slightly different to what this might say. So when I'm riding a bike, if I want to speed up, I pedal faster. If I want to slow down, I put the brakes on. But if I am already moving and I don't do anything, eventually I will stop. Now that kind of is not what this is saying, is it? But actually that's because there are other forces acting on me. If there weren't any other forces acting on me, if I was riding my bike and there were no forces acting on me, I would just carry on moving at a steady speed. But because when I'm riding a bike there's air resistance and there's friction, then actually over time I will slow down. So this is what Newton's first law is describing. Now we're going to look at that idea using this animation here. This is an animation from PhET, which is brilliant physics animations that you can get. Here we've got some random mannequin thing which is going to apply forces to whatever's on this skateboard here, and you can see that it's going to show the force. I'm going to actually show the speed as well on here. And at the moment, hopefully you will agree that there are no forces acting to the sides on the pushing the girl on this skateboard. There is a force down, isn't there? There's going to be the weight pushing down, and there's going to be some kind of reaction force, some contact force pushing back up again. But those forces are balanced. So Newton's first law says that if the forces are balanced, then the object will remain doing what it's already doing. So at the moment, the forces are balanced. The girl's not moving on the skateboard, and so the skateboard isn't moving. Okay, so that's the first thing. So let's see, if I give some force, if I push with a force. Oh, 1 Newton. That's not very much. Let's go for 51 newtons. So when I put 51 newtons, you can see that the speed increases. So when you push with something when there is a resultant force, then you can cause the object to accelerate. And that's what it's doing, isn't it? The speed is going up, so it's accelerating. Let's get rid of that force. So now I've taken the force away, and can you see what happened to the speed? The speed is now remaining constant. So now again, the resultant force on the skateboard and the girl on the skateboard is 0. The forces are all balanced, or there isn't any force pushing to the sides. So the resultant is 0, and the girl continues to move at a constant speed. So this is what Newton's first law says. When the resultant force is 0, then the object will carry on doing what it's doing. And what we can do is we can apply a force. So if we apply a force in the same direction as the object is moving, then the object will accelerate. So the object is continuing to accelerate. And let's take that force away. Oh, let's take that force away. Oh, he's just fallen over. So we've taken that force away. So that the speed is at a constant amount. If I now, so when the force is now balanced again, when there's 0 resultant force, then the speed is constant again. If I now put a force in the opposite direction to the direction that's going, then you can see that the speed is going down, so the object is decelerating. And this is what Newton's first law says. When there's a force in the opposite direction to the direction that an object is going, then the object will decelerate. Let's get rid of that force. When I get rid of the force, there is a balanced force, 0 resultant force. So all of the forces are balanced, a 0 resultant force, and so the speed is constant. So if I want to accelerate this object, I will give it a force in the direction that it's moving. So it's moving from left to right. I'm going to give it a force in that direction, and the object speeds up. Get rid of the force, the object carries on going at a constant speed. Give it a force in the opposite direction to the direction it's going, and the speed goes down, it decelerates. Get rid of that force again, and the object carries on going at a constant speed. Now if I was to push the girl from the side, then I could also change the direction. So that's the other thing that I could do. So I can either speed something up with a resultant force going in the same direction as the object is travelling. I can decelerate the object if the force is in the opposite direction to the direction the object is travelling. Or I can change the direction if I push from the side, basically. But on this simulation I can't do that. Okay, so that's a nice little demonstration of Newton's first law. So here's a little task that you could do to show what you know from what we've done so far. So a little table here. Down the left hand column is what the object is already doing, either at rest or moving. And then the middle column here shows you what the resultant force is, either 0 or non-zero, and it also describes the direction. And the right hand column is the effect that that will have on the object. So what I'd like you to do, what I think would be a good idea, is if you were to copy down that table and then see if you can fill in the gaps with all of those things, and then I will go through what the answers will be in a second. Okay, so if you want to pause it there. Okay, have you paused it? You got to go? Okay, so here's the answers. So if something is at rest and there's no resultant force on it, then the effect on the object, that object will stay stationary. It won't be moving. If the object is moving and there's a 0 resultant force on it, then the velocity stays the same. You have a constant velocity. It won't change. The acceleration or the deceleration will be 0. If the object is already moving and there's a non-zero force in the same direction as the object is moving, then the object will accelerate. If the object is moving and there's a non-zero force in the opposite direction to the direction that it's moving, then the object will decelerate. So hopefully you got those. Okay, so that is our first lesson on forces and motion and looking at Newton's laws. And this is what hopefully you can do by the end of this lesson. Hopefully you can describe that Newton's law states that a non-zero resultant force will cause a change in motion and a zero resultant force will not. That is basically Newton's first law. And you can also describe the effect of zero and non-zero resultant forces on the motion of the objects. Okay, well, that's that for this lesson. I've been Mr. Baker. Thanks very much for watching, and I will see you next time.